special about these systems is that they are so-called complex adaptive systems. Now, here's one. I don't think it needs much introduction. And the way we understand complex adaptive systems is being things that consist of many, many different entities, acting, reacting to each other, without any centralized control, having a so-called emergent behavior, creating a pattern of behavior that looks like something we can recognize, like a city, an industrial region. Now, there are two very important properties that complex adaptive systems have that most people are not aware of, that are of great interest to us if we try to understand how these things evolve and how to shape them towards a more sustainable future. One is that they are complex, and I will explain in a second what I mean by that. And the second is that they evolve, thus they're intractable. Big word, and let me tell you what it means. So complexity is understood by some scholars as the inability of single language or a single perspective to describe all the properties of a system we observe. So we have to have these multiple languages. We have to have these different perspectives just to understand a complex system. And that has a very, very important consequence. Just one second. Now, and that is that nobody really understands everything. By necessity, you don't understand everything. You also don't know anything. Regardless of what politicians, managers, conspiracy theorists tell you, nobody's in control. We all are, but in very roundabout ways. And the second property I alluded to is intractability. Now, intractability is something that evolving systems do. What you're looking at now is a graphical depiction of this fairly complex idea. The white line is us progressing through time, making decisions, events happening, and things evolving over time. All the red things are all the futures that did not happen but could have. Right? If I had driven my bicycle a little bit less careful this morning, I could have been hit by a truck. I would not have been here. And maybe I would have not inspired somebody. I hope I do. And then the world would have looked differently. And that's true for every single one of us doing actions every single day all over the place at the same time. And intractability also means that there is no faster way of predicting the future other than just going there. You cannot jump into the future. You have to go through the steps. So what does this really mean? Well, it means a couple of things. If we are to have a sustainable world, we have to consciously shape it. But nobody knows what's going on, nobody can control everything, and nobody can predict everything. Now what? Well, I wouldn't be an engineer if I wouldn't say, well, it's here, it's real, now let's deal with it. Let's do something about it. So what we try to do at our group at TU Delft is to say, well, let's represent the real world in all of its facets, all of its complexity, and try to grow possible futures. We use sophisticated internet technology, semantic web, some of you might know it as Web 3.0, to collect these multiple perspectives, these multiple ways of thinking, different types of data, and bring them together into computer entities that we call agents. Agents are things, in this case, they're governments, they're firms, they are people, they're consumers, and they know things and they do things. So an agent is a thing that does things to other things, people like to say. So what we do is create these gardens of things, agents. We let them interact, they do things to each other and with each other, and patterns of behavior emerge. What you're looking at is an agent-based simulation of the Dutch electricity sector. This is work done by a graduate student of ours, Emile Chapin, who has looked at what happens to the Dutch electricity sector under different government conditions, under different types of policies. And since we cannot predict, what we do is the following. We run thousands upon thousands upon thousands of experiments, gigabytes and gigabytes of data. Things run for a month on the biggest computer we own at TU Delft. And they generate many possible ways of how the world could look like. Again, we are not predicting, as nobody can do that. We're just exploring where the things could go. And out of this pattern, out of this data, a pattern starts to emerge. And one specific pattern that I can, oops, I'm sorry about that. One pattern that I can tell you is that the current way how the EU has set up CO2 trading is not going to work. Be prepared for very expensive electricity and a very little reduction in CO2, because what these patterns tell us that firms really like taxes, which sounds very paradoxical, but taxes are predictable. You know how much you will be taxed, and that also means that you can invest in these very expensive, very large physical systems that you need to create in order to reduce CO2. Okay, so this is a very specific type of insight for a specific model. What I would like to share with you is 4 more fundamental insights that stem both from complexity theory and theory of evolution and from our experiences with working with these things. So, how does one grow or evolve a sustainable socio-technical system, a sustainable society? Well, first, you have to start bottom up. Decentralized is the key here. Each and one of you might have that one idea that, if connected correctly to others, will bloom into something. Think about why, for example, people don't like what happened in Copenhagen for the climate thing. There was no one centralized decision. Well, there never could be one and never will be one. We can never possibly agree what sustainability even is, and let alone how to deal with it. So we just have to act. Have you heard this morning a fantastic example of greenhouses? Just go out and build them, and things will come. Second, we have to learn to fail gracefully. This is a very weird thing, because when you think about it, evolution is all about trial and error, not trial and success. We like success because it's so special. But what we really do a lot is make mistakes all the time. Now the question is, how do we make mistakes in such a way that we can recover from them? How do we do social experiments? In a city like this, there's enough social problems that we have to try to solve. So how do we do that without making a big mess? How do we try different things in the environment without destroying it? And how do we learn from things that went wrong? So that's something we really have to address.